Hello everyone, welcome to the series of units and measurements. In this lecture today, we are going to cover errors. So the definition of error is no measurement is perfectly accurate and the deviation from the true value is called an error. And the value of measurement is often expressed in true value plus minus error, that is it lies in the error range. So the true value is the exact value of the measurement that is supposed to be true. So the measurement that we have in physics is always inaccurate to certain level, and that we express it as in a range format like true value plus minus error. Now error can be classified on two bases. The first is the cause of error and the second is quantitative. In the cause of error, we have got two types of error. The first is systematic error and the second is random error. And in the quantitative aspect, we can have four error types. The first is absolute error, then the mean absolute error, percentage error, and the relative error. Here percentage error and relative error are very much related. Relative error is the ratio, whereas percentage error is in the percentage form of that ratio. So one by one we will cover all these types of error. So at first, systematic error. So systematic error is the error that occurs due to the measurement instrument. Now these type of error are also called repeatable errors. Now they have a definite pattern which can be avoided. Now there are various causes of systematic error. The first one is instrumental error and observational error, environmental conditions, theoretical errors. So instrumental errors contains the error in which the fault is in the instrument and it can be corrected. So everyone must have experienced a calibration issue in their compass, either in their phone or due to some friction in the compass, that is a physical compass. So this is one of the very common experience that we all have. So that is a type of instrumental error. The second is observational error, that is the incorrect reading. So everyone must have experienced this error while measuring anything with scale. So when scale gets worn out, its reading sometimes gets worn off as well. So we may experience certain kind of difficulty while making observation. So that is known as observational error. Now it can also be corrected by replacing the scale or the measuring instrument. Now the third kind of pattern due to which this type of error occur is the environmental conditions. So for example, suppose you are measuring mass of certain quantity that is very much affected by level of moisture in the environment. Now when it is raining outside, then obviously the moisture would be high, so as compared to when the humidity level is low. So the measurement of the same quantity will be different. So this can be attributed to the environmental conditions. Now the fourth kind of error is theoretical errors. Here we often study physics with very large assumption, or we study the ideal cases. Now for an example, let us consider we always solve the problem of force with an assumption that sometimes we assume that there is no any friction while sliding. So obviously the amount of force would be less in calculation as compared to in the real case example. So that is a form of theoretical error. Now these all errors can be avoided by either changing the instrument or rectifying it, and they have a certain pattern. That's why they are known as systematic error. Now let us shift our focus on random errors. Now random errors are the irregular errors, and they can be avoided by making repetitive calculations of the same value. So they are also known as irregular errors. Irregular error without a fixed pattern is known as random error. They are caused by unpredictable fluctuations in the experimental conditions. The mean value A mean of a measurement AN, like if you assume that the measurement is AN, where N is the nth measurement of the same physical quantity, then the mean value of that is taken as the true value. So it is the arithmetic mean. Now let us see the quantitative aspect of these errors. The first one is absolute error. This is the difference between the true value and the measured value, and it is always positive. That's why we notify it as modulus of A minus AN, and it is always positive. Now mean absolute error. So for every measurement we will have a certain difference from the true value. So the mean of that absolute errors is known as the mean absolute error, and it is denoted by delta AM. Now relative error is the ratio of the mean absolute error to that of the mean value of the measurement. It's called the true value. It's called the relative error. Now mean value of the measurement is also known as the true value. So relative error would be equal to the mean of absolute error divided by the true value. Now percentage error is the same in the percentage form. Now calculation of errors. So if we are doing some calculations based on multiple physical quantities, then obviously if two physical quantities have an error, they both have, we are calculating A and B, and A have the absolute error of delta A and B have absolute error of delta B. So the resultant error upon subtraction or addition would be delta x equals to plus minus delta A plus delta B. Here delta x is the range of error, so maximum error would be delta A plus delta B, and the minimum error would be delta A plus delta B. So the measurement would lie in this range. Measurement error will lie in this range. Now the error in multiplication or division would be given by delta x by x equals to plus minus of delta A by A plus delta B by B. Now error in exponent, we can assume x would be a to the power n divided by a to the b to the power m. Now the error in exponent would be delta x by x equals to plus minus n delta A by A plus m delta B by B. We will solve exercises based on this in the next class. Thank you. If anyone has any doubt, then they can ask.